Okay, welcome everyone to this series where we'll go through a walkthrough of the entire May-June examination series of Maths Exam Code 9709. I'll try my best to do as many videos as I can explaining every single paper all the way from 2010 to 2020. But before we can actually start solving the question, there are a few disclaimers that I have to make. Firstly, I will not be going through every single step when I'm answering the question, and the reason for that is if I do that, it will simply be too time consuming and inconvenient for those who are watching it. I don't want to have a 1 hour, 2 hour long walkthrough. To keep things concise, I really recommend you guys to go and revise your basic algebra. This includes laws of indices, laws of surds, quadratic equations, logs, etc. The basic algebra that you have probably learned in your GCSE. So I hope you are well versed with your basic algebra. Secondly, the way I'll be answering the questions by explaining the question first, answering it in the best possible manner I know, and then explaining the common mistakes the students usually make. And thirdly, I'll try to keep my answers as simple and concise as possible so that you are able to understand easily. However, you can always rewind the video and you can always ask questions in the comment section below. I'll try my best to answer them all. So starting with our first question, this is May-June 2010 Pure Maths variant 11 or variant 1-1. The first question is expressed in terms of radians the acute angle x radians is such that tan x is equal to k. Okay, so basically they want us to express the different terms of 1 to 3 in terms of k, and tan x is equal to k. The first question is tan pi minus x. Now you can solve these questions using algebra, or you can also use a unit circle to solve them. Now, drawing a unit circle is not something that comes to candidates' mind when they look at a question like this. So most of the students will probably go to solve them using algebra. However, if you're someone who has done it using unit circle, that's fine and good. So I would solve using algebra 2 for the first two questions, because that's the one students usually go for when they see a question like this. So I can rewrite my tan pi minus x as tan pi minus tan x. This is the same as, let's say if I had t 3a plus b, I can rewrite it as 3a plus 3b. I'm using the same logic over here. So I'm expanding my brackets and writing it down as tan pi minus tan x. Now I know from the question itself that tan x is equal to k. So this will be k over here. And I know from the question, I know from my calculator and from my trigonometric knowledge is that tan pi is equal to 0. So 0 minus k is simply minus k, and that's your answer right there. Moving on to part 2. Now part 2 is slightly tricky, and this is something you have to be careful of. So again, when you get a question, instead of solving it and trying to get the answer, look at the number of marks. So it gives you an idea of what you want to do or what they expect you to do. So second question is tan 1 by 2 pi minus x. Now I can again draw a unit circle to solve, which I won't because it will take, it's not something that students would want to do, and I'm trying to avoid to go through every single alternate method to keep the video concise. So we'll just solve this one using algebra as well. Now I can rewrite this as 1 by 2 pi minus tan x, and I can replace my tan x with k. But here's the problem. The problem is 1 by 2 pi of tan is a math error. There is no solution for 1 by 2 pi. So we can't expand the brackets as we did in part number 1, because tan 1 by 2, there is no answer for tan 1 by 2. So we have to choose a different route. Using algebra, but a different route. I know that tan is equal to sine by cos. So I can rewrite this as sine 1 by 2 pi minus x divided by cos 1 by 2 pi minus x. And then I can use my laws of trig laws. Just a quick rewind. I think I did this before. Okay, sorry for that. So just a quick recap. Sine A minus sine B is the same as sine A multiplied by cos B minus sine B multiplied by cos A, and cos A minus B is the same as cos A multiplied by cos B plus sine A multiplied by sine B. These are simple trigonometric rules that you guys need to know in your A levels. Technically, this is something you will study in detail in A2. However, these are basic formulas that just memorize them. It's not that difficult. Also, you'll find them in your booklet, in your formula booklet when you're answering the question in examination. So just rewrite your expressions using that formula. So if I do that, I will have sine 1 by 2 pi multiplied by sine x minus cos 1 by 2 pi multiplied by cos x divided by cos 1 by 2 pi cos x plus sine 1 by 2 pi multiplied by sine x. Now I know that from my calculator and from my trick knowledge that sine 1 by 2 is 1. And I know that cos 1 by 2 is 0. So this entire thing will cancel off, and this entire thing would cancel off. Sorry, sine 1 by 2 pi and cos x. I know that this entire thing would cancel off, and this entire thing would cancel off because cos 1 by 2 pi is equal to 0. And over here, I know that cos sine 1 by 2 pi is 1. So if I reduce it using simple algebra, this would simply be 1 multiplied by sine x divided by 1 multiplied by I did write the formulas correctly. Sine cos, sorry, my bad, I have to rewind. My mistake, I did not write. Sorry, my bad. So I can expand them using sine 1 by 2 pi cos x minus sine x cos 1 by 2 pi divided by cos 1 by 2 pi cos x plus sine 1 by 2 pi sine x. Now I know from solves from calculation that sine 1 by 2 is equal to 1. You can just put the value in the calculator. Sine 1 by 2 is equal to 1, and I know that cos 1 by 2 is equal to 0. So this entire thing would cancel off because 0 multiplied by cos x is 0, and this entire thing would also cancel off because again cos multiplied 0 multiplied by anything is 0, and this would be 1. So I can reduce this as 1 cos x by 1 sine x, which is the same as 1 by 10. What's my logic? 10 is equal to sine by cos. So therefore 1 by 10 is equal to cos by sine, simply flipping my fraction. And I can rewrite this as 1 by k because 10x is equal to k. And there you go, that's the answer to the question. Right, the part 3 to the question. Now part 3 is slightly tricky, and for part 3 I would draw a unit circle. Now you can solve part 3 using algebra. However, if you use algebra for this question, for this part, it will become extremely messy, and that's not something I would recommend. For instance, we know that, let me start the question. Okay, there we go. We know that sine x is the same as cos multiplied by cos x multiplied by 10x. What's my logic? Well, tan is equal to sine by cos, so therefore sine will be equal to tan multiplied by cos. And I can replace my tan with k, and then I'll have cos x by k. The problem is, what do you do from this point onwards? Now you can use more laws and more rules of trick and try to replace cos with somehow tan. It will become lengthy, it will become confusing, and for 2-mark question, is it really worth it? In my suggestion, in my humble opinion, I don't think so. So for this part only, I would draw a unit circle. For the first 2 parts, you can also solve them using unit circle, but it's something that I would not recommend because you can solve using algebra and it's not that lengthy anyway. So if I draw a unit circle, this would be k, the value that you want to find out. this is your 1 because the coefficient of sine x is right over here. The coefficient of sine x is 1, so this would be 1 over here. And this is our hypotenuse. Hypotenuse in this case would be k square plus 1 square. Using a simple Pythagoras theorem, a square plus b square is equal to c square. So we know that sine x is the same as opposite by hypotenuse. So I can rewrite this entire term as opposite over hypotenuse. Opposite is 1, so therefore it will be 1 over hypotenuse. Hypotenuse is k square plus 1. The 1 square, sorry. That's it. There's your answer right there. You'll get 2 marks for that. You can do using algebra, and why do you want to spend 4 or 5 minutes doing simple 2-mark question? Also for this question you need to know unit circle, and I hope you guys can go and revise unit circle. It's something important that you have to know for your A-level maths. Again, common mistakes students would make in this question is they will spend too much time. These questions are the first 2 parts are just for 1 mark, and you should not be spending for more than 1 minute. I would suggest to try the first attempt. If you have any 1 mark question, make your first attempt. If you're not getting it, make a second attempt. If you're not getting it, leave it, move on. You don't need 75 or 75 to get an A star. If you make a few mistakes here and there, it's fine. You have to keep account of time. You will have higher mark question, more difficult question later down in the paper. So don't waste time doing questions for 1 mark and spend 5 minutes doing it. So the common mistake students would make in this question is spend too much time when they don't have to. Anyway, moving on. Question number 2. Find the first 3 terms in the expansion of. Okay, so we have to use binomial expansion to expand our term. However, the question says to expand in descending order. That means we have to expand, but from 5 to 0 rather than 0 to 5. With respect to the power of 2x, which is a in this case. So if I use my binomial expansion, I will have 5 choose 5 using my combinations, multiplied by 2x raised to 5, multiplied by minus 3x raised to 0, plus 5 choose 4. Again I'm going in descending order, multiplied by 2x raised to 4, multiplied by 2x raised to 5, 2x raised to 4, multiplied by minus 3x raised to 1, plus 5 choose 3, multiplied by 2x raised to 5, multiplied by minus 3x raised to 1, raised to 2, my bad, 3 and 2. So you're going descending order, so you have to go from 5 to 3. You can keep on going, but you don't have to do that because the question just asks you to find the first 3 terms. From this point onward, all you have to do is simply simplify, and that's it. That's your answer right there. So 1 multiplied by 32. I'm using basic algebra to simplify my expression over here. So you can probably do it using your calculator as well. So you'll have 5 over here. If you have 5 over here, 16 because 2 raised to 4 is 16. Multiplied by minus 3x plus over here you will have 7, 10, 8 cube multiplied by 9x square. If I simplify that down, I would get my final answer to be 32x square minus 240x cube plus 720x. Again, all I'm doing is using my combinations and binomial expansion to expand and using my algebra to simplify. Common mistake is students will make a silly mistake when simplifying the entire thing down. You miss a few signs here and there, you don't multiply properly, and you lose marks. So be careful with the algebra and these type of questions. So anyway, part 2, expand. Okay, so we have to find the coefficient of x square in the expansion of the 2 terms. So if I rewrite it down, I have 1 plus 2x square multiplied by 2x minus 3x raised to 5. Now I know that 3x raised to 5, the first 3 terms I found in my first part, so I can simply rewrite it using the terms I found in my first part. That would be 32x raised to 5 minus 240x cubed plus 720x. All I have to do from this point is expand. So 32x raised to 5, 1 into that, and then minus 240x cubed plus 720x plus 64x raised to 5 plus 2 over here. So plus, then we have minus 480x cube. Let me expand it over here. 480x cube by x square plus 720. It's not 721, 4 because 2 multiplied by 721, 440 x divided by x square. We have to find the coefficient of the term with x only, with x power 1. If you look at all of these terms, clearly the x power is 5, so we don't have to think about this one. Neither is this power 1. This is power 1, and these two will cancel off to be power 1. So we'll have plus 720x, because x cube divided by x square is simply x, simply minus 480x, minus 480x. Again, the question asks us specifically to find the coefficient of x. So all the other terms with power of x not being 1, we'll simply ignore them. So this will basically give us 480, not 480, 240x, and that's your answer. So what's the coefficient? 240 is the coefficient. That's your answer right there. Okay, going back to the question, what common mistakes students will make in this question? Again, simple silly mistake when we are simplifying. It's very common. It's very sad to see students make silly mistakes in questions as easy as this. These are questions where you can get easy marks, simple marks, straightforward. Okay, question number 3. The ninth term of the, okay, so you have progression question, right? So the ninth term of arithmetic progression is 22, and the sum of the first 4 terms is 49. Find the first term of the progression and the common difference. So basically, you have to set up simultaneous equation and solve for the question. So let me just go on and set up my equation. So I'm setting up my equation for the sixth term first. A minus 1 and d, and I'm setting equation for my for my sum of the first 4 term, for the sum of the first 4 term, which is 49. I'm using my formulas from the arithmetic sequence, which you should know from your content. 49 is equal to 1 by 2a plus 4 minus 1 multiplied by d. And all I have to do from this point is solve my simultaneous equation and get my answers. So if I take my first equation and I try to make my a the subject, let me erase that quickly. So if I solve the simultaneous equation, I should get 2 answers. I should get a is equal to 10, and I should get d is equal to 1.5. Now I can go and solve the simultaneous equation one by one using all the algebra, but I am not going to do that. Why? Because I'm trying to make this walkthrough as concise as possible, at the same time letting you guys know all the steps, all the basic things you need. So this is all you have over here, simultaneous equation, and if you solve the simultaneous equation properly, you should get a is equal to 10 and d is equal to d is equal to 1.5. Okay, part B of the second. The nth term of the progression is 46. Find the value for n. Okay, the nth term of the progression is 46. Okay, so basically you'll set up an equation for the nth term. The nth term of the progression is, so 40, not 46, is it 46? Okay, is it 46? Yeah, 46. So 46 is equal to a plus n minus 1 d. Now I know from the first part that the value for a is 10 and value for d is 1.5. All I have to do from this point on is, solve my simple algebraic equation. Minus 1, 1.5. If I do that, I will get the value for n to be 25, and that's your answer right there. Okay, what is a common mistake students will make in this question is that they will forget the formula. So make sure you guys memorize all the formulas for arithmetic sequences and for geometric sequences, and those are the only two that you need to know for your A-level, AS level maths. Okay, question number 4. The diagram shows a curve y is equal to 6x minus x square and the line y is equal to 5. Find the area of the shaded region. Okie dokie. The first thing that you have to do is find these 2 coordinates. Find the 2 coordinates where then we can use our integration to solve. So how can we do that? We can set up a simultaneous equation situation for the curve and the line, because if we do that, if I set up an equation for y is equal to 6x minus x squared and y is equal to 5, I can find the two coordinates where they both intersect, which is basically at this point and this point, and I need to know the x coordinate of these two coordinates so that I can use my integration to find the area. So let's do that. So 5 is equal to 6x minus x squared. Y is equal to 5, so I'm simply replacing my value for y to be 5, and I'll have a quadratic equation situation over here. Minus, I can rearrange that, minus x squared plus 6x minus 5. If I use my calculator, I should get the values. If I use my calculator or my quadratic formula for that matter, I should get my values of x to be for my values. So let me use my calculator super quickly. Ding, 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 ding. I should get my values of x to be 5 and 1. Now I can use my integration. Again, when you want to find the area under the curve, always integration of the straight line minus integration of the curve. Okay, that's the safest way to go. So integration of the straight line, 5 dx, 5 and 1, minus, and subtracted by the integration of the curve, which is 6x minus x squared dx and 1 by 5. And that's your answer. If you try to solve for this one, integrate for these two and get the answer, and that would be your area under the curve. So let's do that super quickly. This would be 5x, 5 by 1 subtracted by integration of 6x would be, this would be 2, this would become 2, and this would be 6 by 2 x squared minus x by 3 by 3. Okay, that's the integration right there, right? And from this point on, you can use the calculator and find the answer. Replace your value for 5x with 5 and 1, get the answer. Same thing for the one. Simple integration that you should know from your content, and that would be your answer right there. And if you solve for it either by using a calculator or by using, manually using again the calculator, that would be you will get your answer for area under the curve to be 10 1 by 3, which is the same as 10.33, and that's your answer right there. Okay, moving on. Let's see what else do we have. Okay, that's it. That's another question. So question number 5. Again guys, I mean, I know that you would want me to go through every single algebra, but if I do that, I mean, the video will be more than 1 hour, and it's not something that it's not something that you will find convenient, or nor do I think most of you are simply here to know the basic mechanism of how I'm getting the answer. So question number 5, the function f of x is equal to 2 sine square x, sorry, my bad, minus 3 cos square x. Okay, the first part, express f of x in the term a plus b. Okay, so it will basically express in terms of cos x only. A straightforward question. I can replace my sine square by 1 minus cos square x. How am I doing that? I'm simply using my property of trigonometry or rules of trigonometry. Cos x square, 1 second, let me just hold it. Okay, so sine square x plus cos square x is equal to 1. I'm using that property. So if I move cos to the side, I'll have sine square x is equal to 1 minus cos square x minus 3 cos square x. Okay, this is the same as 2 minus 2 cos square x minus 3 cos square x. This is the same as 2 minus 2 square x minus 2 cos square x minus 3 cos square x is the same as 2 minus 5 cos square x, and that's your answer right there. So value for a is 2 and the value for b is minus 5. Part 2, state the greatest and the least value of f of x. This is a tricky question. For this part 2, you need to draw a curve. However, you do it mentally. If you want, you can do it on the paper, but I would recommend you do it mentally. Why do you want to waste time? If I draw a rough sketch of the curve, try to draw a rough sketch of this, I would have something that would look something like this, not exactly, but something like this, and this point over here, because my amplitude is 5, this point over here would be -3, because for 2 minus 5 is -3. So the greatest and the least possible value for x, that means the greatest value and the least value. The greatest value is 2 and the least value is -3. Again, I can do that by simply drawing a rough sketch of the curve in my mind, and I know that the amplitude is -5, and we are starting from 2. So 2 minus 5 is -3, and then you have the rest of the following. For this question, you need to know how to draw trigonometric curves. So make sure to revise that topic if you don't understand what I'm doing over here. So the answer over here would be -2 and -3. Now, why do I recommend not to draw the curve in the exam paper for this part? Is because it is just a 2-mark question. Why do you want to draw a curve for 2-mark question, which will take probably at least 3 minutes? So not something I would recommend. Okay, moving forward. Part number 3. Solve for f of x plus 1 is equal to 0. Okay, let's do that. Let me erase this quickly. Okay, so I know that f of x is equal to 2 minus f cos square x. Now we want to solve for f of x plus 1. So therefore 2 minus 5 cos square x plus 1 from the question plus 1 is equal to 0. So -5 cos algebra that you can solve is equal to 0 minus 1 minus 2. Okay, minus cos square x is equal to -3 divided by -5, and therefore cos is equal to x is equal to cos inverse -3 and -5. Okay, and that is the value for cos, and that gives us the answer to be x is equal to either my mistake. Again, silly mistakes are extremely common. So if I move the root to the other side, it will be root plus minus 3 by 5 cos x. Therefore x is equal to cos inverse root of plus minus 3 by 5, which will give you x to be 0.085 or x to be 2.46, and that's your answer right there. What are the common mistakes students will make in this question? I really don't think there's any common mistake you can make. It's a pretty straightforward question, and I don't know if you can make any mistake over here. Okay, question number 6. A curve is such that dy by dx is equal to 3x 1 by 2. Okay, minus 6, and the point is given. Okay, find the equation of the curve. If we integrate the derivative, you can get the equation of the curve. So let's integrate this. 3x 1 by 2 minus 6 dx. This gives us integration. This will become plus 1. So, and there's 3 divided by 3 by 2 x 1 by 2 plus 1 minus 6x plus c. C is the constant you have to figure out. Y is equal to, if I simplify this entire thing down, this will become 2x 3 by 2 minus 6x plus c. Now I know from the question that one of the coordinate is 9 and 2, so I can replace 9 and 2 into my equation. So 2 is equal to 2 9 3 by 2, because I want to find the value for c plus c, and I can use simple algebra to find the value for c, which would therefore be c is equal to 2. I'm using simple algebra to find, and that's your answer right there. So what's the equation of the curve? Y is equal to 2x 3 by 2 minus 6x plus 2. There you go. Part 2. Find the x coordinates of the stationary point on the curve and determine the nature of the stationary point. So to determine the nature of the stationary point, we need to take a second derivative, and to find the stationary point themselves, we need to equate our derivative to 0. So let's do that. To find the coordinates of the stationary point, we need to equate our derivative to 0. That would give us 3x 1 by 2 minus 6 plus 6 divided by 3 is equal to x 1 by 2 using simple algebra. Therefore, x is equal to root of 1 by 2. 6 by 3 is simply 2. 6 by 3. X is equal to, if I use my calculator, x is equal to 4. So that is x coordinate for our stationary point, right? So to find the nature of the stationary point, we have to take a second derivative. Second derivative would be this x, okay, dy by t. Okay, so second derivative for this would be 1 by 2 goes down, it will be 1 by 2 multiplied by 3x 1 by 2 minus 1 minus 0. So because when you have a constant, derivative of constant is 0, so this would be 1.5 or 3 by 2 x minus 3 by 2 is equal to 0. All I have to do is replace my value for x, and if I do that, why is my computer lagging? If I do that, I said white color, okay, I would have 3 by 2 4 minus 3 by 2, and the answer for that would be a positive. So if you use your calculator, you will get a positive answer for this one, and whenever you have a positive answer for second derivative, it means that it is a minimum point. If you have a negative answer for a second derivative, it means that it is a maximum point. So there you go, that's your answer right there. A common mistake students might make in this question, I don't really know any common mistake except that you guys forget how to take a second derivative and how to take the first derivative, so, and how to integrate. So basic integration derivative is something that you might forget, or you might make mistake over here. Okay, that's it. Okay, so that is part number 1. That is part number 2. Okay, question number 7. This is question number 7. Sorry, my bad. This is question number 7. Okay, question number 7. The diagram shows part of the curve y is equal to, okay, for which crosses x. Okay, dokie. The normal to the curve is, okay, show that the equation of the equation. Okay, dokie. Okay, so we have to basically find the equation of the line AC. To find the equation of the line AC, first we need to find the coordinates of A. Now we know that the curve y is equal to 2 minus 18 by 2x plus 3 crosses the x-axis, and at the x-axis the coordinates of y is obviously always 0. So if I can replace my coordinates into my equation and solve for x, 0 is equal to 2 minus, these are the coordinates that you will have at your x-axis, and these are the coordinates that you will have in your y-axis. Okay, because x is always 0 in y-axis and y is always 0 at x-axis. So if I solve for 2x plus 3 plus 3, if I solve for x, I should get the answer to be, if I solve for x in the video based algebra, okay, so it will be minus 2 multiplied by 2x plus 3 is equal to minus 18. I'm shifting my 2x plus 3 to the other side along with my 2 to the other side, and if I use my algebra, I should get the answer to be, x is equal to 3, and therefore the coordinates for A are 3 and 0. So you find the equation of the curve AC. You have the coordinates of A, but we don't have the coordinates for C. But we can find the coordinates for C by equating by finding the coordinates at the point y is equal to 0, and by finding the coordinates at this point. So if we can find the coordinates at this point where x is equal to 0 for the equation, we can then theoretically find the value for C. So if we do that, so y is equal to 2 minus 18 to 0 plus 3. 2 multiplied by 0 is 0, so it will cancel off. Y will be so 2 minus 18 divided by 3. So 2, if I use my calculator, 2 minus 18 by 3 minus 4. So y is equal to minus 4. Therefore the coordinates are minus 4 and 0. So I have my two coordinates. I can find my gradient, and I can also find my equation of the curve. So let's do that. The gradient of the curve is simply using the formula y2 minus y1 divided by x2 minus x1. And I know that the equation are always in the form y is equal to mx plus c. All I have to do is use this formula, find the value for m, and then substitute any two coordinates from a or by form coordinates from c, and find the value for c, and that would be the equation of the curve, and that would be the answer right there. This is something very basic, and I hope you guys can do that, and it's not something that you need anyone's help. Simple algebra right there. Okay. So the next question, find the length of BC. Once you find the equation of AC, we have, the coordinates. We know that the coordinates of A are what were the coordinates of A? We know the coordinates of A are 3 and 0, and we know the coordinates of C are 0 and 4. All you have to do is use the length of the equation curve, which would be x2 minus x1 whole square plus y2 minus y1. Just use this equation and get the answer. And if you do that, so let's do that. So root of x2 would be, in this case, let's make this x1, make this 2. So x2 would be 4, 0 minus 3 whole square plus y2 0 minus 3 whole square. Okay, so that would be 3 square plus 3 square, 4.24. That's your answer right there. What are the common mistakes you might make? Is you could make simple silly mistakes. Again, silly mistakes is one of those common themes you'll have across the entire paper. Okay, question number 8. It's been a long paper. Question number 8. The diagram shows the triangle ABCD. The coordinates are given. Find the gradient of the curve AB. Use the formula for M. Okay, you have to find the gradient of the line A to B. We know that the coordinates of A are 3 and minus 2. And we know that the coordinates of B are 15 and 22. To find the gradient of A to B, all you have to do is use our equation y2 minus y1 divided by x2 minus x1. If I do that, I will get my gradient to be 2. And I know that the triangle ABCD, the gradient of AB and AB, I know that the gradient of AB is 2m. So this is 2m. So 2 is equal to 2m. And so therefore m would be 2 divided by 2, which is 1. And that's your answer right there. Find the coordinates of C. Okay. We know that m is equal to 1, and we know that the line A to C, from the question itself, the line A to C has a gradient to be minus 2m. So therefore minus 2 into 1, which is equals to minus 2. Minus 2 is the gradient of the line A to C. So therefore y is equal to minus 2x plus c. I'm simply using my equation formula, y is equal to mx plus c. Now I know that the coordinates of C are coordinates of C are not given, but the coordinates of A are given. So I can replace the coordinates of A into my equation. So this would be minus 2 is equal to, minus 2 is equal to, use another color. Minus 2 is equal to minus 2 by 3 plus C. Minus 2 plus 6 is equal to plus C. C is equal to 4. Therefore y is equal to minus 2x plus 4. That is the equation of the curve y is equal to equation of the curve A to C. But the question asks us to find the coordinates of C. Now I know that at the y-axis, the coordinate of x is always 0. So I can use that to find the coordinate of C. Y is equal to 2 multiplied by 0 plus 4. 2 multiplied by 0 is 0, and so therefore y is equal to 4. So what are the coordinates of C? 0 and 4. There's the answer right there. The perpendicular bisector of AB meets BC at D. Find the coordinates of D. Okay. A perpendicular bisector is the line that intersects another line at a 90-degree angle. Okay. So The perpendicular bisector of AB meets bisects AB bisects. Okay, so first we have to find the perpendicular bisector of AB. For that we have to find the midpoint of AB. So I can use the midpoint formula that would give me 15 plus 0 divided by 2 on my x and 22 plus 4 divided by 2 on my y. That would be 7.5. This would be 26 divided by 2 is 13. That is the midpoint of B to C. By using that midpoint, okay, let's keep the midpoint aside for us. Let's keep the midpoint aside for a while. So let's find the gradient of the perpendicular line AB. Now I have the coordinates of B and I also have the coordinates of C. So I can use my equation formula y2 minus y1 x2 minus x1 to find the gradient of B to C, which in this case would be, which is already given in the question, to be 2m. So with m is 1, so therefore the gradient of B to C is basically 2. So I can use my formula y is equal to mx plus c. Now I know that a perpendicular line, I know that a line and its perpendicular line, if I multiply both the gradients, I'll get minus 1. So if 2 is the gradient of the line B to C, then the gradient of the line of the perpendicular of that line will be minus 1 divided by 2, which is minus 1 by 2. So therefore y is equal to minus 1 by 2 x plus c. I know that the midpoint has the coordinates 7.5 and 13. So I can, if I plug that in, I will get 7.5 is equal to 1 by 2 13 plus c. So therefore c would be if I do my calculation properly, hold on, I think I made a mistake. The perpendicular of AB meets BC, so I have to find the midpoint of AB. Okay. For this part, first I need to find the midpoint of AB. So for that I would simply 15 plus 3. I'm using my midpoint formula for A and B. 15 plus 3 divided by 2 is x, and 22 plus minus 2 divided by 2, which will give me 9 and 10. That's the midpoint of AB. Mid. Okay. Now I need to find the perpendicular bisector of AB. I know that AB has the gradient to be 2m and m is 1. So therefore the gradient of AB is 2. I know that a perpendicular line and a line and its perpendicular, the gradient will multiply to give us minus 1. So we know that the gradient of A to B is already 2. So therefore the gradient of the perpendicular of that line will be minus 1 divided by 2, which is minus 1 by 2. Y is equal to minus 1 by 2 x plus c. I can plug in the values for the midpoint. That would give me 10 to be minus 1 by 2 9 plus c. 10 plus 4.5 is equal to c. C is equal to 14.5. Either you can write it down as decimal or you can write it down as fractions. It's completely up to you. And that's the equation of the line. Y is equal to 0.5x minus 0.5x plus 14.5. That's the equation of the line. That's the equation of the perpendicular of the line AB. Right. We have this line intersects BC at point D. Find the coordinates of D. For this, you'll have to first of all form an equation for D. So if I can do that, if I form an equation for B to C by using the simple standard method I already know, I should get the answer to be, hold on, let me calculate. I should get the equation to be y is equal to x plus 7. Again, I'm just using my standard method to find the equation of the curve B to C. In the question itself, the coordinates of B are given, the coordinates of C are given. You have to use equation, you have to use the expression y is equal to x f mx plus c. M for B to C is simply 1, so y is equal to x plus c. You can substitute the coordinates of B into y and x and find the value for C. If you do that, you will get C to be 7. And these are your two equations, and you have to solve simultaneous equation situation to find the midpoint of find the points where the both intersects, which is basically the point D. And if you do that, you should get the answer for D to be let me do that, D to be x, D to be y, and y to be minus 12. So these are the coordinates of D. Again, simultaneous equation situation, I'm not solving it because I don't want to make the video extremely long and inconvenient. Okay, moving on to question number 9. Express f of x in the terms. So the function is given. Question number 9. Okay, part 1. Express f of x in the form a x minus 1. So basically you have to rewrite, this is f of x, and I have to rewrite it in a completing square format. So let's do that. So how do we completing square? So let's move our 2 outside. I'm using my completing square method to find the completing square of the f of x. So we'll move to the outside. So again, we can make our coefficient of x to be 1, and then we will take our value for b, which is in this case minus 12, subdivided by 2, and then square it. Plus 12 by 2 is 6, plus 6 square, plus 7. Now in any expression, if you're adding a number, you have to subtract that number. Minus 2 into 6 square. Why? Because if I open the brackets, I have to first multiply it with 2. So technically this is not just 6 square, this is 2 multiplied by 6 square. So if I'm adding 2 multiplied by 6 square, I must subtract 2 multiplied by 6 square. If I do that, I would get 2. Now over here I have a quadratic equation. I have an equation in the form a minus b whole square is equal to a square plus 2ab plus b square. So I can rewrite it as x plus our value for b is 6, sorry, x minus our value for b is 6, x minus 6 whole square plus 7. It's not 7 minus 2 is 2. I use my calculator. 7 minus 2 multiplied by 36. If I do my math properly, I should get hold on, one second. Wait. See, again I made a silly mistake. Hold on. If I move 2 to the outside, this will become x square minus 6x plus 7. We'll take our value for b, which is 6 in this case. We'll divide by 2 and then we'll square it, which is basically 3 square plus 7. And if you're adding 2 multiplied by 3 square, you must subtract 2 multiplied by 3 square. Why am I multiplying it by 2? Because you see I have a bracket in front. So if I expand this bracket, it's technically me adding not just 3 square but also 3 square multiplied by 2. So I must subtract 3 square multiplied by 2. So that should give me 2x minus 3 whole square plus 11. If I use my calculator, okay, I should get minus 11. So therefore our value for a is 2 and our value for c is minus 11. Part 2 is very straightforward, very easy, finding the range of L. The answer is f is greater than 11. This is something very straightforward, you should know from your functions questions. Okay, part number 3. Find the set values for x for which f of x is less than 21. We know that f of x is equal to 2x minus 3 square minus 11. So we have to find the value for f of x less than 21. So therefore 2x minus 3 whole square minus 11 is less than 21. I have inequality that I have to solve. So if I solve the inequality, if I expand the bracket, I will have a square plus 2ab plus 2ab plus b square I'll have a quadratic equation situation over here. Minus 11 is less than 21, and 2x square minus 12x, 18 minus 11, 18 minus 11 is 7, plus 7 is less than 20, minus 21 is equal to 0. So 2x square, again I'm simplifying the expression, so 7 minus 21 gives us minus 14. Minus 14 is equal to 0. From this point, either I can use my quadratic formula or I can use my calculator mod 5 and then 3, which is basically a quadratic formula in the calculator itself. I'm talking about the calculator Casio f of fx 991es series. Okay, in that calculator, in those calculator, mod 5 3 gives you the quadratic equation itself. Just put the values of a, b and c, or you can use a long method by writing down entire quadratic equation and then solving it. If you do that, you will get the value to be x to be x to be greater than minus 1 and x to be less than 7, and that's your answer right there. Okay, next question. Okay, erase this super quickly. Okay, next question. Question number 4. F of g is defined with the term find the value for x. Okay, so basically it's the composite function that we have to solve. If I make the composite function, I will have something like this. All I am doing is I'm simply inserting my g into my f. So my that sounds funny. So f of g of x, all I'm doing is I'm taking my g function and inserting it into my x function, into my f function, and that's it, is equal to 0. And all I'm doing is I'm solving for it. So this will give me 4x squared minus 24x plus minus 24 square plus 14 plus k is equal to 0. Okay, right, I know that this is my constant. So if in a quadratic equation you have your a square minus 2ab plus b square, I know that my b square is 14 minus 14 plus k. All I have to do, because I know that this is equal to 0, I can solve for the discriminant. Discriminant is b square minus 4ac is equal to 0. So in this case, that would be minus 24 square minus 4 into a into c is equal to 0. If I solve the equation, I'll get the value for k to be 22, and that's your answer. Question number 10, and the final question after a long time, after a 1 hour long video. So anyway, let's solve the final question. The unit vector in the direction OB, we know that OB is your OB is, where is OB, right? Unit direction of OB. We know this is a parallelogram. If this is a parallelogram, if this is a parallelogram, OA is equal to in this situation, if I want to go from O to B, first I need to go from O to A and then from O to C, which is the same as adding O to A and O to C. Sorry, that was my calculator. So 133, which is O to A, 133, which is O to A, plus 3 minus 1, which is your O to C. This should give us the answer 4i, 2j, 4k, and that's your answer, O to B. The acute angle between the diagonals of the parallelogram. Okay, for this question, we have to first find, so this question we have to find O to B and O to C, A to C. We know that we have found O to B. We need to find A to C. A to C is C minus A, so that is 3 minus 1, 3i minus 1j, 1k, minus 1i, 3j, and 3k. That gives us the value minus 2I 4j minus 2k. Now from this point we just have to use our formula for finding the acute angle, find the angle between the two lines. Let me erase this super quickly. Okay, right. So the formula is a dot b, the dot product of ab, divided by the modulus of ab. Cos is equal to cos theta. So we know, so let's try to find the dot product of a and b. The dot product or the scalar product of a and b in this situation would be for these two, ignore this one. For this one would be 4 multiplied by minus 2 plus 2 multiplied by 4 plus 4 multiplied by minus 2. The dot product for this case would be minus 8. The modulus for OB will simply be root of 4 square plus 2 square plus 4 square, which gives us the value to be, what does it give us? Let me calculate that. Which gives us the value to be 6. And the modulus of AC, which is 2 square plus 4 square plus 2 square, which is root of 4. So therefore our theta would be cos inverse minus 8 divided by 6 multiplied by root of 4, which gives us 108.8. Now 108.8, it's not your acute angle, it's your obtuse angle. This is your 10. Let me use a darker color. This point is 108.8. So if you want to find the other 2 points, is also 108.8. All you have to do is 360 minus 108.8 minus 108.8 divided by 2, because all of the sides will add up to 360. And if you do that, you will get the answer to be 77.4. Let me double check that. 360 minus 105.8, my bad, 105.8. If I do that, 105.8 minus 10, I'll get the answer to be 74.35, and that's it. That's your answer right there. Okay, final question. Finally, the perimeter of the parallelogram correct to one decimal place. So the perimeter of the parallelogram, you have to calculate the length of all the 3 sides. I know that the length of all the 3 sides. So basically, first of all, modulus of A to C. Now I know this is a parallelogram. So therefore, O to C is the same as A to B, and O to A is the same as C to B. O to A and O to C, both our O to A and O to C, both the vectors are given. So let's find the modulus of that and multiply it by 2 to get the other 2 sides. So 1 square plus 3 square plus 3 square. This will give us root of 19. Now because O to A is the same as O to B, to find O to B, just multiply this by 2. And it will do the exact same thing for O to C and O to A to B. O to C modulus will be plus 1 square is equal to 3 square plus 1 square plus 12, not 12 plus 1 square, root of 11. And all you have to do is just simply add up our values, and that should give us root of 19 multiplied by 2 plus root of 11 multiplied by 2. That should give us the answer to be 15.35. And that is the end of the entire paper. I know it was lengthy, I know it was extremely long and tedious, and I tried my best to make it concise. So feel free to give me feedback in the comments below so I can improve my presentation, and let me know if there's anything that I did wrong that I can correct it. And feel free to like and support, because solving past paper is not an easy task, to be honest. Hopefully you liked the video.